This video is going to work through a few examples of percent increase and decrease problems. And I want to start off by just talking about percents and how they work and how I think about them. So I always think of percents as a pie. And if I have a whole pie, that's my 100% of the pie. If I'm increasing the amount of pie that I've got, then I get to have a whole pie and a little bit more. So I've got pie and a bit. If I'm decreasing it, then I had a whole pie, but I took out a little slice. So I started at my 100%, but I'm taking out some percent and seeing what I'm left with. So thinking of percentage in that way can help us really make sure that we're thinking about what we're doing as we're calculating percents, increases and decreases. The other thing that you should notice is that percent is always a number out of 100. Percent, of course, meaning per 100. And usually we think of that as the part of the whole, the 100 representing the whole amount, and the part is the percent at the top. When we're talking about percent increase or decrease, the whole is what we start from, or the original amount, and the part is how are we changing? Are we growing or shrinking from the whole? So realizing that it all fits into what you already know about percents can help you organize and set up your problems. We're going to take a look at a word problem, so make sure you read it over first. And let's see what we're doing here. We've got an increase problem, so my change will be growing from $3,600 to $3,900. So the original amount that David is earning is $3,600. Okay. The new amount is $3,900, which means that the change is adding $300, right? From 3,600 to 3,900. And the problem is asking me to find the percentage increase. So let's define that as our unknown. Let the percent increase equal X. So now thinking about all of this information, let's think about where it's going to go in our relationship. And so I know that the original percent is always per cent or per 100. So that's pretty fixed in my equation. And the percent increase, or how it's changing on the percentage side, I've defined as X. It's equal to the original, or the whole that I started out with, which is 3,600. And the change, or the part that's different, is that it increased by $300. So now it's just a proportion, and I can use my means and extremes to cross multiply and solve for X. Just to make the arithmetic easier, I'm going to divide the numerator and the denominator by 100. And then I'm going to see if there's any other factors here that are common. And I notice that 3 and 36 are both divisible by 3. So 3 divided by 3 cancels to 1, and 36 divided by 3 is 12. So now when I do my cross multiplication, I get 12x is equal to 100 times 1, or 100. And so dividing both sides by 12, I get that x is equal to 8, which would give me 96. To get to 100, I would need 4 more, so 8 and 4/12, which simplifies to 8 and a third. So this 8 and a third represents the percent increase. So there is an 8 and a third % increase in salary. I want to show you one other thing that's kind of neat about percent change, and that's what if instead of calculating the change, right, by subtracting these two numbers, what if I just set up my relationship to compare the new amount, $3,900, to the original amount, $3,600? If I did that and I cross multiplied, I'm still going to simplify on this side because I can. So divide those both by 100. Divide them both by 3. That's 13 and 12. So now 12x is equal to 1,200. Oh, I'm sorry. 12x is equal to 1,300. And if I divide both sides by 12, x is equal to 100, and there's 100 left over, and I know that that is 8 1/3. So notice that in this instance, the percent that we got, the 108 1/3%, represents the 100% of the pie plus the 8 1/3 increase. So this is the new percent, right, when compared to the 100% original. That's pretty neat. Let's take a look at what happens with a decrease problem. So here, take a minute and read it, please. So here, we're shrinking these pants by 4%, or they do shrink by 4% after the wash. And we want them to be 102%, or 102 centimeters, excuse me, when we're done, because that's the length we actually want to wear them at. So let's identify what we know. We know that the percent change is going to be subtracting or going down 4%. But remember, I'm starting from the whole pie, and I'm just taking out the 4%. So that's really 100% minus the 4%, which means that the percent that we're interested in, or the percent of the pie that we'll have, is 96% of the pie. The changed centimeters, right, the length of these pants after the change is 102 centimeters. Okay? And what we don't know is the original length of the pants. So let's let the original length and that's in centimeters. Let's make that equal to x. So let's see if we can figure out where to set up these things. So we know that the change leaves us with 96% of our pie. Well, 96% is 96 per 100. This represents the original amount. Well, that's our variable. That's what we don't know. And the changed centimeters after it shrank is 102 centimeters. So now I've got my proportions set up. Now I can just cross multiply and solve for x. I'm still going to simplify. So 100 and 96 are both divisible by 4. And 100 divided by 4 is 25. And 96 divided by 4 is 24. So 24x is equal to 25 times 102. And so that is, I'm using a calculator now, 25 times 102. I could do this in my head, but I have the handy dandy calculator. 2,550. And so if I divide both sides by 24, I'm going to get that x is equal to 106 with 1 left over and 1/4 left over, so 0.25. So x is equal to 106.25. Now let's think about what that number means by putting it back up into our original description. So the original length of the pants was 106.25 centimeters. So the pants need to start out at 106.25 centimeters. Okay? So I hope these two examples help you to think about percent increase and decrease problems and proportions in a more clear way. And we'll do some more examples when you're in class. Thanks.